Good morning, my dear students. Welcome to the chemistry class. Today I will discuss the estimation of elements, by quantitative analysis. Previously we have discussed the qualitative analysis, and today we will discuss the quantitative analysis. First we will discuss the Lebesgue method, that the estimation of carbon and hydrogen. In this method, first organic sample weight is taken and then it is burned in excess of oxygen. Carbon is converted to carbon dioxide and hydrogen is converted to water vapor. And then the weight of the carbon dioxide and water vapor is determined. And then the percentage of carbon and hydrogen are calculated. And here in Lebesgue method, whatever apparatus we have used here for carbon hydrogen estimation, it has three parts or units. One is oxygen supply unit, another is combustion unit, another is absorption unit. So first the combustion tube is detached from this absorption tower, and then it is heated and a current of oxygen is passed through it. So here air and oxygen we are taking, we are drying it through concentrated sulfuric acid, then we passing through the soda line, then we are passing through this combustion tube. Hope you can understand. And then it is cooled and connected to the absorption unit, and then the boat containing weighted organic sample is introduced inside the combustion tube. This is the boat where organic sample, weighted amount of organic sample is taken. And then the tube is heated strongly, and compound is burned completely in presence of oxygen. So finally a strong current of oxygen or air is passed through it. If there is any carbon dioxide or any traces of what moisture is present, that will be absorbed here. And here we have taken that for absorption of water anhydrous calcium chloride, and absorption for carbon dioxide we have taken potassium hydroxide. Hope you can understand what I am telling. So the U tube and the potash valves, whenever it absorbs all this carbon dioxide and moisture, then you have to remove, and you have to calculate the increased weight. So that means before you have to before this procedure you have to take the weight of this U tube as well as potash valve separately, and after this reaction, you have to check or calculate the increased weight of each of these that U tube. That means here anhydrous calcium chloride where water will be absorbed, and this potash valve where carbon dioxide gas will be absorbed. And then from this increased weight of this water vapor and increased weight of the carbon dioxide gas, we have to calculate the percentage of carbon and hydrogen in the organic sample. Hope you can understand what I am telling. Now we will discuss the calculation of this, that means hydrogen and oxygen. So first you see here calculation. First you take that, let the weight of the organic compound that will be the W gram, and weight of the water vapor, that you can easily calculate before and after. When you are taking the difference, you are getting the weight of the water vapor. Suppose this is A gram, and weight of the carbon dioxide gas, that will be the B gram. So from here you have to calculate the percentage of hydrogen. So percentage of hydrogen will be what? That will be 2/18 into A by W into 100. Okay, actually 18 gram water contain 2 gram hydrogen. Okay, then A gram water contain how much amount of hydrogen, that you have to do. And this amount of hydrogen is present in W gram of organic sample. So 100 gram contains how much? So this is the percentage of hydrogen. And in the same way you can also calculate the percentage of carbon. That will be 12 by 44 into B by W into 100%. Okay. So in this way you can easily calculate the percentage of carbon and hydrogen. And this method is suitable for the estimation of an organic compound that contains carbon and hydrogen only. If compound contains nitrogen, sulfur, halogens, then the modification is required. That means this process modification is required. Okay. Nitrogen, if there is nitrogen, that you have to remove by the formation of nitrogen N2 gas. Okay. If there is halogen, you have to remove by the formation of silver halide. If there is sulfur, you have to remove by formation of lead sulfate. Hope you can understand. Okay, everything is given in details in your book. Okay, so you have to read thoroughly, then you will be able to understand. Okay, next we will go to the estimation of nitrogen. The two important methods, okay, used for the estimation of nitrogen. Okay, one is called Dumas method and another is called Gelder's method. And this Dumas method is not in your syllabus, only Gelder method is there. So Gelder method we will discuss. Okay. So in this method, a known weight of the organic compound is reacted with concentrated sulfuric acid, and the nitrogen present in it is quantitatively converted into the ammonium salt. As you are adding sulfuric acid, it will form ammonium sulfate, and then you have to react this liquid with the sodium hydroxide solution. Definitely ammonium salt, when it will react with sodium hydroxide, it will produce ammonia gas. Okay, and the ammonia gas evolved, you have to react it with the saturated solution, okay, of a known volume or known strength of the standard acid solution. Okay, standard acid solution you have to take, and the volume of the unreacted acid is determined by the titration with a standard alkali solution, and from the amount of ammonia, okay, evolved, the nitrogen in the given compound can be estimated. Okay, now what is the procedure in case of this Gelder method? There are 3 steps also. Okay, first one is the formation of ammonium sulfide. So you have to take, ammonium sulfate. So first you have to take the 300 to 500 milligram organic sample. Then you have to paste in a long necked flask, okay, that is known as Gelder flask, and about 25 ml of concentrated sulfuric acid you have to add. Then a little potassium sulfate and copper sulfate, okay, or mercury you have to add to it. Potassium sulfate raises the boiling point, okay, and mercury or copper sulfate acting as a catalyst, okay, for completion of this reaction. And the flask is loosely stopped by a glass bulb, and it is then gently heated till the brown color of the liquid first produced and then disappear, and at this point all the nitrogen present in the organic compound gets quantitatively converted into ammonium sulfate. Okay, so next we will go to the distillation with alkali, the Gelder method, okay, or the Gelder flask, okay, whatever we are where we are converted that nitrogenous compound to ammonium sulfate, okay, that you have to dilute it with distilled water, and Gelder liquid is transferred into a large round bottom flask. Okay, then you have to add some porcelain chips, okay, and porcelain chips will help you to avoid the bumping. Actually, whenever the bubbles will be formed, that will be broken, okay, or that will be diminished, okay, by the porcelain chip. Next, you have to add also few pieces of zinc, okay. If there is excess alkali is there, that sodium hydroxide solution, that will react with it, and that will produce hydrogen gas, which can act as a carrier for the ammonia gas. Next, round bottom flask is fitted with the Gelder strap and a water condenser, and the lower end of the condenser is dipped into a measured volume of a standard sulfuric acid solution, and the flask is also filled with a dropping funnel and sodium hydroxide solution is added through it, and the round bottom flask is heated and there ammonia gas will be evolved, and that you have to pass through the no excess standard sulfuric acid solution, and the gel dull straps does not allow the alkali solution to pass into the condenser. So here what is the reaction? Ammonium sulfur is reacting with that sodium hydroxide forming ammonia gas, and then distillation is stopped when a drop of distillate does not turn the red litmus blue color. Next we have to do the titration, and titration of excess acid. The excess acid left is determined by titration with the standard alkali, that is the phenolphthalein you have to use as indicator. Next we will show you the calculation, how we will do the calculation to estimate the nitrogen. So calculation I am showing you. Suppose you take the weight of the organic compound, that will be the W gram. Then volume of sulfuric acid, volume of H2SO4, that will be the molarity of M, that will be the VML. And volume of NaOH, of molarity M, required to neutralize excess H2SO4, that will be equal to V1 ml. Now from here you have to calculate that V1 ml of NaOH, of molarity M, that will be equal to V1 by 2 ml of H2SO4 of molarity M, because you know that sulfuric acid is a dibasic acid, and definitely if you take 1 mole sulfuric acid it will neutralize 2 mole of sodium hydroxide. That is why we are doing this thing. Then the volume of M molar H2SO4 to neutralize ammonia, that will be V minus V1 by 2 ml of H2SO4 of molarity M. So that will be equal to 2 into V minus V1 by 2 ml of ammonia solution of molarity M. Now we know that 1000 ml 1 molar ammonia is equal to 17 gram ammonia or is equal to 14 gram nitrogen. So from here we can write that 2 into V minus V1 by 2 ml ammonia of molarity M contains nitrogen, that will be 14 by 1000 into 2 into V minus V1 by 2 into M into G, mg, octogram. So from here if you calculate you will get that percentage of nitrogen, that will be equal to 14 into M into 2, 2 divided by 100 divided by 1000 into V minus V1 by 2 into 100 divided by W. Okay, so from here if you calculate, you will get 1.4 into M into 2 divided by W and V minus V1 by 2. So here in this case, the process you have to understand, but numericals will come in the examination. Okay, so many numericals are already discussed in your book. Okay, and exercise, some numericals are also given. Okay, that you will do as homework. Okay, and if you check your sample paper of class 11, you will watch that, or you will see that there are some numericals, okay, coming from this part. And this method, that means this general method, is simple and quicker than this Dumas method. Okay, and this method is not applicable to compounds which contain nitrogen atoms linked either oxygen or with another nitrogen, okay, like nitro compound or azo compound, and it is also not applicable like nitrogen present in a cycle like pyridine. Pyridine is a heterocyclic aromatic compound. Okay, next we will discuss the estimation of halogen. Okay, estimation of halogen the same way, but here we have to convert first this halogen, okay, whatever organic compound is present, that you have to heat with the fuming nitric acid. Okay, and definitely in presence of silver nitrate. So silver nitrate will convert this halogen into silver halide. Chlorine is there, silver chloride. Bromine is there, silver bromide. Iodine is there, silver iodine. Then it is, this is insoluble, okay, in water, so it is separated and washed, okay, and dried and wet, and from the weight of the silver halide, okay, you can easily get the percentage of halogen in the given organic compound, that you can easily calculate. Now in this case, what will be the percentage of halogen? I am telling you, the formula I am telling, that percentage of halogen, and this is called Carrias method. Okay, percentage of halogen will be equal to the atomic weight of halogen, X we are indicating halogen, and then molecular weight of halogen, silver halide, into X by W, okay, into 100. Now what is X here? Actually X is the weight of the silver halide. It may be silver chloride, silver bromide. And what is W here? W is the weight of the organic compound, okay, where halogen is present. Okay, so in this way we can easily calculate the percentage of halogen, whatever it may be, chlorine, bromine, iodine, okay, anything is present, that we can easily calculate. Next we will discuss the estimation of sulphur, okay, by Carrias method. Okay, and here also you have to take some known amount of the organic sample, known weight, and that you have to heat it in fuming nitric acid. Sulphur present in the organic compound is oxidized to sulfuric acid, and it is precipitated as barium sulfate by addition of excess amount of barium chloride, and then you have to separate that barium sulfate, you have to wash and you have to dry, and from the weight of the barium sulfate you can easily calculate the percentage of sulfur, okay, present in the organic compound. Now here what formula we will use, and you can do the calculation also, but you are not doing that percentage of sulfur, okay, that will be equal to 32, that is the atomic mass of sulfur divided by 233, okay, 233 is the barium sulfate, okay, there is the mass of barium sulfate 233, into you have to write X by W into 100. Now what is X here? Okay, X is the weight of the barium sulfate, and what is W? W is the weight of the organic compound. Next we will discuss that estimation of phosphorus. The organic compound is heated with fuming nitric acid in a carriers method, okay, to determine the phosphorus. Phosphorus present in the compound will be oxidized to phosphoric acid, which is precipitated by addition of magnesium mixture. Magnesium mixture contain magnesium chloride, ammonium chloride and ammonium hydroxide. So the precipitate of magnesium ammonium phosphate is ignited to obtain that magnesium pyrophosphate, and this magnesium pyrophosphate you have to take the weight, and from there you can easily calculate the percentage of phosphorus. Okay, already method we have shown. Okay, so here percentage of phosphorus you calculate, you can use this formula also. That will be the 62 divided by 222 into x by w into 100. So here also in the same way, x is the weight of the magnesium pyrophosphate and w is the weight of the organic compound. Okay, so in this way we have completed your whole things, okay, from organic chemistry. Okay, actually this part left. Okay, and now we will discuss different types of question in live class. You can ask question from any organic portion if you have any doubts. Okay, and from today we will take the revision test also. Today I will try to give you a revision test. Okay, so and next you have half yearly examination, and best of luck for your half yearly examination. Thank you.